For most of modern astronomy, the solar system felt finished. We had counted the planets, mapped their paths, and pushed the unknown to distant stars. But over the last decade, something uncomfortable has crept in. A pattern that should not exist. A quiet suggestion that something big is missing. Far beyond Neptune, in a region where sunlight is weak and objects drift slowly, astronomers began noticing strange behavior. Small, icy worlds were not moving randomly. Their orbits lined up. They leaned the same way. They clustered as if they were responding to a shared influence. Not collisions, not chance. Gravity. At first, the idea sounded extreme. Another planet would mean we misunderstood our own neighborhood. But the math kept pointing in the same direction. When researchers tried to model the outer solar system without an unseen object, the simulations fell apart. Add one large distant planet, and suddenly the chaos made sense. This would not be a close neighbor. It would not rise in the night sky. If it exists, it lives in deep darkness, taking thousands of years to circle the sun once. Slow, cold, hidden, yet powerful enough to sculpt the orbits of worlds billions of kilometers away. The unsettling part is not that we have not seen it. The unsettling part is that its fingerprints appear to be everywhere. The outer solar system is supposed to be messy. Once you get past Neptune, gravity weakens, objects move slowly, and orbits should point in every possible direction. That randomness is exactly what astronomers expected to see. But that is not what showed up. When researchers started cataloguing the most distant known objects, something felt off. A handful of these icy worlds had orbits that lined up in space. Not just vaguely similar, they pointed the same way. Their closest approaches to the Sun clustered on one side, their orbital planes tilted in the same direction. If this were only 2 or 3 objects, it would not matter. But the pattern held as more were discovered. The odds of this happening by chance were low enough to make people uncomfortable. Astronomers tried the obvious explanations first. Maybe Neptune was responsible. Maybe passing stars had nudged things long ago. Maybe it was a bias in how telescopes searched the sky. Each idea helped a little, but none of them made the pattern disappear. The real problem was stability. Over billions of years, these orbits should have spread out. Gravity tends to erase neat arrangements over time. Yet the clustering looked long-lived, as if something were actively maintaining it. When scientists ran computer simulations, the results were blunt. Without an extra source of gravity, the system refused to behave. The orbits scattered. The pattern collapsed. But when they added a single massive object far beyond Neptune, everything locked into place. That object did not need to be close. It did not need to interact often. Its steady pull over millions of years was enough. This was the moment the idea stopped being a curiosity and started feeling like a problem that demanded an answer. If this unseen object exists, it would not be a small one. Based on the way it appears to shape distant orbits, scientists estimate it could be 5 to 10 times the mass of Earth. That puts it in a strange category. Bigger than anything in the outer solar system we know about, but smaller than Neptune. Its orbit would be extreme, highly stretched out. At its closest, it might still be several times farther from the Sun than Neptune. At its most distant point, it could be hundreds of times farther out. One full orbit could take 10,000 years or more. This is not another Pluto. Pluto is small, part of a population, and easily influenced by Neptune. This object would be the opposite. It would dominate its region. It would clear space. By modern definitions, it would qualify as a true planet. What makes the idea compelling is how specific the predictions are. The planet's mass, orbit, and tilt are not guessed randomly. They are constrained by the observed behavior of distant objects. Change those values too much and the simulations stop working. There is also precedent. Uranus was discovered the same way. Astronomers noticed that Uranus did not move quite as expected, and the solution was another planet. Neptune was found because of math before it was found with a telescope. The difference now is scale. This planet would be so far away that even powerful telescopes see it as a faint point moving almost imperceptibly against the stars. The case is not closed, but it is no longer speculative hand-waving. It is a concrete hypothesis built to explain a problem that refuses to go away. If a planet that large exists, it feels reasonable to ask why we have not seen it. The answer is distance, darkness, and time. At that range, sunlight is incredibly weak. Even a large planet would reflect very little light back toward Earth. It would not shine like Jupiter or Saturn. It would look more like a dim, slow-moving speck, barely different from the background stars. Movement is another problem. Objects that far away take years to show noticeable motion. Most surveys rely on detecting motion over days or weeks. A planet with an orbit lasting thousands of years barely shifts at all on human timescales. It can hide in plain sight. There is also the issue of where to look. The sky is huge. The proposed orbit covers a vast region, much of it far from the plane where most planets sit. Telescopes are powerful, but they do not watch everything at once. They scan small patches slowly and hope something stands out. Even modern surveys struggle. They are designed to find fast-moving near-Earth objects or bright distant galaxies. A faint planet drifting silently through the outer solar system is almost the worst possible target. Ironically, older data may already contain it. Astronomers often go back through archived images looking for objects that were ignored because they seemed unimportant at the time. A single unnoticed dot recorded years apart could be enough to give it away. The search is not over. It is just slow, and patience is part of the price of looking that far into the dark. Finding a new planet in our own solar system would not be a minor update. It would force a rewrite of how this place came together in the first place. Right now, the outer solar system already looks strange. Giant planets orbit closer to the Sun than models once predicted. Small, icy worlds are scattered in ways that suggest ancient chaos. A distant, massive planet could tie many of these loose ends together. It could explain why some objects were flung outward instead of falling inward. It could even hint at early encounters with other stars while the Sun was still forming. There is also a broader implication. Astronomers regularly find planets around other stars on wild, elongated orbits. Until recently, our own system looked unusually neat by comparison. A distant, eccentric planet would make the solar system feel less like an exception and more like a familiar example. It would also change how we define what is possible to detect. A planet found primarily through its gravitational effects would be a reminder that observation is not just about seeing light. It is about noticing patterns that refuse to behave. Perhaps most importantly, it would shift perspective. We tend to think of the solar system as fully explored because probes have visited every known planet. But those missions focused inward. This would be a reminder that the outer reaches are vast, lightly mapped, and still capable of hiding major players. The discovery would not feel like closing a chapter. It would feel like realizing a chapter was missing. The idea of another planet is unsettling because it challenges something familiar. We grow up learning the map of the solar system as if it were complete, fixed, and settled. But gravity does not care about our diagrams. It leaves traces, and those traces suggest there is still something out there, quietly shaping the edges of our system. If this planet exists, it has been there the entire time. While civilizations rose and fell, while telescopes improved and spacecraft left Earth, it kept moving along its long, cold orbit, unnoticed. Not hidden on purpose, just distant enough to escape attention. Whether it is eventually found or ruled out, the search itself matters. It forces astronomers to question assumptions, to look harder at data that once seemed boring, and to accept that even our cosmic backyard is bigger and stranger than it appears. The solar system may not be unfinished, but it may be less tidy than we like to believe.